Hey, this is Mr. Hansen. I've got a couple of shapes on the board here. First one's a simple square, and I want you to think what would happen if we located some midpoints on this square. Right there, right there, right there, and right there. And we connected those midpoints. So we've made another square. And maybe more generally speaking, it's a parallelogram. The opposite sides are parallel to each other. So this green side here is parallel to that green side there, and the black side is parallel to the other black side. So my question is, does that work for any quadrilateral? And if so, how do we know that it works? Let's take a look at this next quadrilateral. This is no special kind of quadrilateral, really. It's just got four sides. None of them are parallel. I don't think any of them have the same length. Let's find some midpoints. So this midpoint is pretty easy to find here. That one is pretty easy to find. This one, if we make a slope triangle and then find our halfway points there, we know that it's going to be right there. I'm going to just make that a little darker now in black. So right there. And same idea on this last one, it's going to be right there. So let's go ahead and connect these. That line looks parallel to that line. And this line looks parallel to that line. So we have a parallelogram there. It's not a square this time, but it is a parallelogram. You could measure the rise and the run for each of those and determine that they have the same slope. This one has a slope of -1/2 right there, -1/2. And this one also has a slope of -1/2 here. A little harder to see because it's right in the middle of a grid mark. Okay, so with that said, I guess the big question is why? Why does this work every time? Why do you always get a parallelogram? So what I'm going to do is I'm going to draw another line, a diagonal, from here to here. And that diagonal has kind of broken this shape up into two triangles. So I'm going to highlight one of the triangles in red. So here we have the diagonal, something like that, something like that. And then here we have what you call a mid-segment right there. So that mid-segment is cutting the triangle in half, and we know that a mid-segment, because it's made up of two midpoints, we call it a mid-segment. We also know that a mid-segment is parallel to the base of the triangle. So that's kind of important there. And let's just let's choose another color here. Let's choose green. And here's my green triangle. And we also have a mid-segment right there. And we know that that mid-segment is parallel to the base of that triangle too. And since the bases of the two triangles are just a diagonal there, they're both the same. So they have the same base, and then both their mid-segments are parallel to the base. So the mid-segments must be parallel to each other. So the red line, let's do that again. The red line here has to be parallel to the green line there. So that's half the reason for why this is a parallelogram. The other half has to do with the two leftover black lines, and you can make another. You can divide this up using another diagonal just like this, and use the same reasoning there, and then you know that the black lines would be parallel as well. So just kind of an interesting way of looking at quadrilaterals and their midpoints. If you connect the midpoints, they'll always make a parallelogram. Thank you.